in 1974, I was working in Panama on Barrow, Colorado Island, which is part of the Smithsonian. And I got invited by a couple of mammalogists who wanted to figure out the biomass of termites and ants in the canopy because they were studying the silky anteater. And one of their friends in the mosquito abatement district said, well, you could use a fogger and fog and then get all these ants and termites down from the canopy and weigh them and figure out how much food is there. So we spread out these sheets on the forest floor, and they had this really primitive fogger, and we fogged it, and lo and behold, I saw a bunch of carabid beetles coming down, and a couple of them I recognized. What? That species is only known from one specimen in the British Museum. Look at, there's 5, 6, 7, 8, they're dropping like flies. Well, like beetles. And so that's when I took up the collecting method of fogging the canopy. I wanted to do an analysis of the Coleopterus intimafauna of this one species of tree. That's all we fogged, was one Luius amanii, this one tree. And so I did that and put together a little paper. And then, I don't know, maybe it's a couple years later, Peter Raven was very active in the National Academy of Sciences. He called me one day and he asked me, how many species of insects are there in 1 acre of tropical forest? Well, okay, maybe I can figure it out. So with some very simple, naive arithmetic, I came up with 46,000 species. And then I thought, well, gee, if there's 46,000 species there, how much is in the world? And so, like a gazillion people after me made the mistake of scaling up from one tree in Panama to 50,000 trees around the planet, and came up with 30 million species. What's really interesting, looking back on that 1982 estimate of 30 million species, in '94 we started biomonitoring of oil company roads in the Yasuní area of Ecuador. And we wanted to see the impact not only on the Guarani peoples there, but also on the virgin rainforest, which was 20 meters from the roadbed. The different researchers set up their own hypotheses. Mine was that the impact would be very little on the insect fauna because it was prohibited to chop the forest down except right in the roadway itself. And for the most part, that's still true these 20 years later. The difference is the Guarani have become a bit sedentary instead of hunter-gatherers, and they're cutting down a little hectare here and hectare there. But for the most part, the forest is still there. And after 20 years of follow-up studies, the insect intimafauna in the canopy of the forest has not changed. The balance is still all there. And so we have somewhere around 15 million insects that we've collected now from the canopy using the fogging method. And what we now know is that there are over 100,000 species in 1 hectare. We also know from those studies that there are 3.2 times 10 to the 10th individual insects and their relatives in the same hectare. Okay, now think that's 1 hectare. There are 17 billion hectares in the Amazon basin, and there's more than 450 different kinds of forests. So just simple math tells you that the 30 million estimate is so conservative, I'm swimming in it. It's going to be way beyond that. 85% of biodiversity on the planet are insects and their relatives. If you remove the tropical rainforest of 269 species per hectare and the 100,000 insects, you're going to lose all those insects as well. So it's the human being's impact on the environment that's going to cause the extinction. I think Paul Ehrlich wrote about this in Population Bomb, or one of his books, about you're flying along an airplane and you look out and see the wing and you see a rivet pop out. And then there's another rivet, and you wonder how many rivets pop out before the wing falls off. And that's the question that we have about the interrelationship of the species, the trees and the insects, how much do we remove as human beings from the environment until the entire ecosystem collapses?